Find the exact value of each function. Since it says exact value, we should try to use our special triangles that I have written off to the right-hand side already. Cosine of negative 210 degrees. If you look at the axes in the bottom right-hand corner, negative 210 degrees would be counterclockwise, and it would be 30 degrees past negative 180. We're placing it about right there. So this would be a reference triangle with a 30-degree angle. Opposite of the 30-degree angle is 1, but since this is cosine, what we're really interested in is the adjacent side, which is going to be negative square root of 3, since we're going to the left, and the hypotenuse is 2. So adjacent over hypotenuse will make this equal negative square root of 3 over 2. For sine of negative 7 pi over 4, you can change that to degrees if you wish. So negative 7 pi over 4 would be negative 7 times 180 over 4, which would equal negative 315. So a negative 315 degree angle would be almost a full turn, except it's going to wind up being 45 degrees short of doing a full 360 degree turn. So we draw a reference angle down to the x-axis. This will be a 45 degree reference angle. So our opposite side is 1, our adjacent side is 1, and our hypotenuse is the square root of 2. So since we're doing sine, that will be the opposite side 1 over the square root of 2, but we do have to rationalize the denominator by taking it times the square root of 2 over the square root of 2, which means the sine of negative 7 pi over 4 will be the square root of 2 over 2 with a rationalized denominator. 34 is determine the period of the function. So notice this function starts at the origin and then goes upward and then downward. That is not a full period. It's still got to complete its negative journey before it gets back up to its starting point. So from start to end, this has a period of 6. Not in your typical degrees, but it is still a full period equal to 6. 35, a wheel with a diameter of 18 inches completes 4 revolutions in 1 minute. What is the period of the function that describes the height of one spot of the outside edge of the wheel as a function of time? It's a lot of fancy words there, but what's important is that it takes 4 revolutions in 1 minute. So the question is asking you, how long does it take to make 1 revolution? And since there are 60 seconds in a minute, and if it makes 4 revolutions in 60 seconds, we'll just take 60 divided by 4. This has a period of 15 seconds. This part right here, the diameter of 18 inches, has nothing to do with the period. It could have a diameter of 18 inches. It could have a diameter of 18 feet. If it's still making 4 revolutions in a minute, a period is still just 15 seconds. Find the amplitude if it exists and the period of each function, then graph it. So the amplitude of this one is the 4, so the amplitude is 4. The period, since it is a sine function, will be 360 divided by the b value, which is 2. We have a period of 180 degrees. So then we're ready to graph the function. So since it is a sine function, it starts at 0, 0. And it will end its full period after 180 degrees. It will hit the x-axis halfway between the start and the ending point at 90. And it will hit at high point all the way up here at 4 with an amplitude of 4, and its low point down here at negative 4. So this is 1 full period. Continue that pattern if I wish. I can do it one more time. And this could be a 2nd full period. And I could even do it to the negative side. So it has a low point down here and a high point right here if I follow the pattern. And that makes 3 full periods. (38) is y equals 3 cosecant of theta. So the question is find the amplitude, and even though it does have an a value of 3, there is no amplitude, because with cosecant, the a value does not mean amplitude. The period is still going to be 360 divided by the b value. This time the b value is 1, so the period is 360. And this function is related to the sine function. So we're going to start out by graphing 3 sine of theta. So 3 sine of theta starts at 0, 0. And since the cosecant function has a period of 360, so does the related sine function. So the midpoint, 180. And with an amplitude of 3, we will go to 93 and 270 negative 3. So this is the related sine function. But ultimately what we're trying to graph is going to be the cosecant. So I'm going to do the cosecant in blue. Everywhere that there is a x-intercept on the sine function, there will be an asymptote on the cosecant function. So right there, right there. There's going to be another one right there. And then I draw my U-shapes, hitting the peak and the valleys and approaching the asymptote. So that is just one full period. 40 is we're going to graph y equals tangent of 2 theta. Again, there is no amplitude, even though the a value is 1. It does not stand for amplitude, so no amplitude. It is a tangent function, so the period is going to be 180 this time, divided by the b value of 2. So we have a period of 90 degrees. And then with tangent, we're going to graph the asymptotes first. So the asymptotes are found by taking 180 over 2 times the a value, or the b value, which in this case is 2. So that will give me 45, and then we will do odd multiples of 45. So that would be 45 times 1 is 45. 45 times 3 is 135. 45 times 5 is 225. We can do 45 times negative 1, which is negative 45, and so on. So those are going to be my asymptotes. So I'll draw those in at negative 45, positive 45, 135, 225. It can continue that same pattern as long as I want. And then the asymptotes will be our S shapes that run through there. Going to be pretty long and skinny because we do have a very small area between the asymptotes. And just remember that halfway between the asymptotes is where it hits the x-axis.